Alrighty, friends. So today we will be doing the front side of the notes, which is the graphs. The back side is the algebra for inverse functions. Hold on, I'm looking for my notes. All right. So inverse relations, move this down. So inverse relations, the simplest way to explain that is simply switching X and Y. So we will switch X and Y. Okay, we will switch X and Y. So question number 1 says, find the inverse of the following relation. So a relation doesn't have to be a function. It doesn't have to follow the vertical line test. You can have any points you want to, and it is considered a relation. So to find the inverse, all we do is switch X and Y. So I'm going to write my inverse. And all I'm going to do is switch X and Y. So my first point is 3, 1. My inverse function will be 1, 3. I'm not going to say them all out loud because I don't want to mess you up, but I'm going to write them down on the board. You write them down on your paper and then look up and make sure that we have the same thing. Do y'all get the same points? We just switched X and Y, pretty simple. Next, it talks about the graphs of inverses. The graphs of inverses reflect over the line Y is equal to X. So I'm going to sketch that line on my graph to show you that when we're done, we're actually going to graph the relation and its inverse, and it will reflect over the line Y is equal to X. Let's see if I can get this on here. Okay, there's the line Y is equal to X. Sorry, it's hard to draw straight lines with this pen, but it is a line that goes through the origin and the slope is up 1 over 1, up 1 over 1. So it's going to go from corner to corner. So it's the line Y is equal to X. And inverse functions reflect over this line. And when we graph this, you'll see what I mean. So what I'm going to do is graph my relation. And I'm going to graph my relation. I'm going to graph this in blue, and then I'm going to graph my inverse in red. And it says that I am going to plot and connect the points for my relation. So I'm going to start with the point 3, 1 over 3, up 1, put a point. My next point is over 3 and then up 6. And it says that I'm going to connect the dots as I go. This is just like our dot to dot pictures. So connect the dots, 0, 6, connect the dots. And just like our mystery pictures, we want to connect the dots as we go. Otherwise, you're going to get a mess. And then I have 0, 1, and I will connect the dot. So that's my relation. That was my first set of points. Now I'm going to graph the inverse. So I'm going to graph the inverse. I'm going to graph it in pink, so that you can see the difference. And I'm going to do the same thing. I'm going to plot the points, connect the dots. So my first point of my inverse is 1, 3. Over 1, up 3, put a point. 6, 3. Over 6, up 3, put a point. And I have to go in the same order. 6, 0. Connect the dots. And then 1, 0. Connect the dots. Do you see how my two functions, they're not functions, sorry, how my two relations reflect over this green line? Can y'all see it?
Yes.
Okay, so pictorially or graphically, we can see if functions are inverses by how they reflect. So that's kind of an easy skill, just looking at the two graphs and seeing if they reflect. You can see if a relation and its inverse, or sorry, and another set of points are inverses by checking each point and making sure that they swap the X and Y point parts. Any questions over with points or with a graph inverses? Anything so far? You just switch X and Y. So, and again, a relation and its inverse will reflect over the line. Y is equal to X. All right. Moving on. So the next one, or the next question says that we've got these, graph the inverse for the functions below. All three of these are functions because they pass the vertical line test. So this, if I run if I run a pen through it, it doesn't have any repeating X values. Same thing here, no repeating X values, no repeating X values. So pretty much U's are okay, V's are okay. What's not okay for a function is it can't overlap itself, so it can't look like a C. So it can't look like a C. All right, to do this, and I'm going to have you guys do these. To do these, I'm first going to sketch on the line of Y is equal to X. That's the line that goes from corner to corner. My inverse should reflect over that line, so it should be a good indication if I did this correctly, because my inverse should reflect over the line. And what I'm going to do is I'm going to take a look at each one of my functions, and I'm going to find some points on that function. And so my first graph, I'm going to start with the beginning and end, and then I'm just going to find the intercepts are good. So I've got 4 points that I've identified that I'm going to jot down. My second function, I'm definitely going to have the beginning and the end. And then the inverses are good. Or sorry, inverses. The intercepts are good, but I'm also going to get that maximum point. I need to have enough points on my graph that I can trace the shape. I don't have to have every single point, but 4 or 5 is usually good. And for my last, I'm going to have the beginning and the end. I think that the points that are shown would be good. So I'm going to start, and this is the same exact thing that you're going to do on your homework. I'm going to start with jotting down the points from my function. So my first function, I've got -7, 4. And I'm just going to go list these points. And I'm going to jot down the points for my second and my third graph. And so what you're going to do is you're going to write down the inverse points and then sketch the inverse. Or you have to write down these as well. One thing that I don't want us to forget is that as soon as we graph it, we have to determine if the inverses are functions. We don't want to forget that part of the question. What do we do to find the inverse? It's the top fill in the blank of the page. Switch X and Y. So I'm going to write my inverse and I'm going to do it in pink. I'm going to start with the third graph because it's got the least amount of points. So I want to walk you through it. So if I switch X and Y, my first point is going to be the same. My second point, 4, -1, 1, 2, and 1, 6. Everybody see what I did there? Here's my function. This is my inverse. So I go plot my inverse and I connect the dots as I go. So these started from left to right, and that's how I named my points. I'm gonna plot these and I'm gonna connect the dots just the same. So I start with -6, 6. And I know that this one is gonna have an arrow because my other one had an arrow. It's hard to see, but there's an arrow there. Then I go to 4, -1. And I connect the dots. One over 1 up 2. Connect the dots. 1, 6. And I connect the dots. Can you see that the red graph reflects to the black graph over the green line? Do y'all agree? This is a question on your quiz. So this is like 10 points of your quiz that you are given a graph. You need to write down the points and then make the points for the inverse and plot the inverse. That is 10 points of your next quiz. Can you do it? Yeah, I hope so. So that is what we're going to do for the other two questions. But first we need to answer, is the red graph, is it a function? So remember, it can't have anything that looks like a C. So it can't have anything that looks like that overlaps on itself this way. So when I look at the red graph, does it overlap on itself? You also can't have vertical lines. Those don't work either. What? You can have horizontal lines. You cannot have vertical lines. No, this is not a function. So my inverse is not a function. You can't overlap. So you can't have vertical lines. You also can't overlap like this way. So, So like, look, see how the graph right here, it overlaps. So like right here, I have 2 spots that I could go to. Oh. It can't overlap this way. It can overlap. It can be like this. It can be a U, but it can't be a C. So it's okay if it's like this, but if you turn it on its side, it doesn't work. So do you have an idea? Is this one going to have an inverse that's a function? If you have a U and you turn it on its side, does that work? No. No. So I can tell you even without graphing it that this one is also not a function. What about this one? A diagonal line. If you flip it, is it still going to be a diagonal line? Yes, it's going to have the same shape. And is a line a function? Yes. So this one will, yes, be a function. Okay, I'm going to start writing the points of my inverse and then sketching my graphs. I would like for you to do the same. Look up if you need any help. I'm actually working backwards. I'm going to do the middle graph and then I'm going to do the left graph. No, you can think about it. Letters in the alphabet, X comes before Y.
Oh, wait. Wait, this. What on the same line? Here.
What do you mean?
Why needed? On the left, all the things that you see on the back. You would like to you like to be guys, what they say.
So the second graph, does everybody see how this is reflected? Mine's kind of janky because it's not easy to write with this pen, but it reflects over the line. What happens with the first graph? What do you notice? What do you notice with the first graph? It's exactly the same line, basically because it reflects over this line. So you get the exact same line. Yeah, it's the exact same line. Again, these are questions directly off of your quiz. I hope that you can look at two graphs and tell me if they're inverses, or if I can give you a graph and you can graph its inverse. Any questions with the front side of our notes? It's graphing. So on your homework, when you take a look at your homework, the first two questions are just writing out a list of the inverse. And then the next question, the whole rest of the paper, you can see I have lots of writing, but it's just me jotting down the points from my function and then the points of my inverse and plotting it. So that's the whole front page of your homework. We good? Any questions? Okay. So that's the front part. Don't forget on questions 3 through 8, you have to identify is the function, sorry, is the inverse a function? And remember that it pretty much is. You can have a U, you can have a V, you can have a diagonal line, but when you start having anything that's like a C, it doesn't work. Okay, anything that overlaps doesn't work. On to the back. Okay, onto the back, it says that inverse functions switch blank and blank. What should go there? X and Y, very good. It's going to switch X and Y. If your problem isn't written as Y equals, then fix it. So change f of X to Y first. Okay, so that's what we're going to do. When I look at this problem, it's not Y equals, so I'm going to fix it. So this is the same thing as Y equals 2/3 X plus 2. This one is already Y equals. This one is already Y equals. This one is not. I'm going to rewrite it. So anything that's not Y equals, I rewrite it as Y. All right, next. This is still the first thing. I have to have it as Y equals. Everything's Y equals now. I'm going to switch X and Y. So I'm going to switch X and Y. And I draw myself arrows just so I remember what it is that I'm doing. So I'm going to switch X and Y. Switch X and Y. Switch X and Y. Switch X and Y. And I'm going to rewrite the problem. So I'm switching X and Y and I'm rewriting the problem. So now it will be X equals 2/3 Y plus 2. Step 2 says solve for y. And then last, once you have y equals, we're just replacing it with the notation for inverse. And that notation, instead of f of x, has a little -1. So there's a little -1 up there. I'll write it bigger so that you can see it's f of -1. Sorry, f to the -1 power. No, I'm not done yet. So this is step 2. I need to solve for y. So to get y by itself, I have to undo every operation. And so I have to start with, I'm adding 2. So what's the opposite or inverse of adding 2? Subtracting 2. So I'm going to bring over the 2 and subtract 2. So I get x minus 2 is equal to 2/3 y. All right, if I've got 2/3 over here, if I'm multiplying by 2/3, I can bring it over bit by bit. And if I'm dividing by 3, I can bring over and I can multiply by 3. So I get 3x minus 2 equals 2y. So I just brought over the 3. And then now the 2 is multiplying. So I got to divide everything by 2. Y will be all by itself now, so I can write my inverse function. So it's the inverse function equals 3 and then x minus 2 divided by 2. Yeah. What I want to point out is that all the operations are opposite. So it's a good way to check yourself if you did it correctly. So when I look at the original problem, this says multiply by 2 and I'm dividing by 2. This says divide by 3, I'm multiplying by 3. This says add 2 and I'm subtracting 2. All of the operations are opposite or inverse. Let's do the next one. So the next one is already written as y equals. I'm going to rewrite it switching x and y. So I will get x equals 2 plus y divided by 4. Now I'm going to do all of the inverses. Yes, take the pass. So the inverses, I'm dividing by 4, so I'm going to multiply by 4. And rewrite. So I get 4x is equal to 2 plus y. Oh, yay. Only one more step to get y by itself. I have a positive 2, so I'm going to bring over and subtract 2. So I get 4x minus 2 equals y, but I have to rewrite it as an inverse. So I'll have inverse and that is my answer. And I can double check that in the original problem, I was dividing by 4. Now I'm multiplying by 4. I had a positive 2. Now I have a negative 2. All the operations will be inverse or opposite. The next one. First, I have to switch x and y and then solve for y. So I'm going to have x equals y plus 4 to the 6th power. Okay, so to undo something to the power of 6, I have to take the 6th root. And so that looks like this one is the 5th root. So I have to take the 6th root of both sides. So I have to take the 6th root of this side and the 6th root of this side. And that's what makes these cancel. So that I'm just left with the 6th root of x equals y plus 4. That's how I undid parentheses raised to the 6th power. I just have one more step. I am adding 4. So to get rid of add 4, I have to subtract 4. So I get the 6th root of x minus 4. It doesn't go inside. Equals y, but I need to rewrite it as inverse. Any questions so far? I am just undoing operations. So my original problem had to the sixth power, and my inverse has the sixth root. Those are inverses. My original function had +4. My inverse has -4. They're inverses. So for my next problem, I have to first rewrite switching x and y. So I have x equals the fifth root of y plus 3. So we're going the other direction. If I have the fifth root, to undo that, I can raise everything to the power of 5. So on the x side, I'm going to raise everything to the power of 5. And that will undo, these undo each other. So now on the left, I have x to the fifth power is equal to y plus 3. What's my last step to get y by itself? Yep, subtract 3. So I get x to the fifth power minus 3 equals y, but I need to rewrite it as inverse. Otherwise, I've got two y equals equations and they look like what you started with. So you have to denote that it's an inverse by writing the inverse function. X to the fifth minus 3. This is the bulk of what you'll be doing today, is just writing the inverse functions on the back. You have 6 of them to do at the top. I would say do question 12 and 14 very last. After you've done everything on your homework, then do question 12 and 14. And last, we're going to talk about how to prove if two, we know how to prove if two if two graphs are inverses because they have to reflect over the line y is equal to x. We can prove if two equations are inverses, and we learned how to do this last time. It's not called FOG, it's called f of g of x. And f of g of x and g of f of x, so both compositions have to equal x. And if they do, then your equations are inverses. So these both have to equal x. And I will show you what that means. Basically, when you plug one function into the other, all the operations will undo each other. We're going to actually start with the functions on the right so that I can kind of show you how this works. So I have to do both. I have to do f of g of x, and I have to do g of f of x. I have to do both of them. Oops, I'm missing parentheses right there. So to do this, I have to write the f function. This is the f function, and I have to leave myself a space where I've got the x. So I'm going to write 1/2. Leave myself a space. Oh, that might not be a big enough space. Okay, so I have to write the f function, and I leave myself a space where the x is, and I'm going to plug this whole function inside of it. Okay, so I plugged in the other function. Now I'm going to take a look and I'm going to see if anything starts to cancel. So what I notice first is that I'm taking the cube root and I'm raising it to the third power. These are inverse operations, so they cancel. So I'm going to rewrite without those operations anymore. So I still have 1/2. Now I have 2x plus 3 minus 3. Scooting that over a little bit. All right, now I look and I can distribute in the 1/2. When I distribute in the 1/2, 1/2 times 2, they cancel. So now I'm left with x plus 3 minus 3. What is plus 3 minus 3? 0. So that cancels. And what am I left with? X. That's awesome. If I can do the same thing with this, then that means these are inverses. So this is what I mean. Everything will start to cancel. So for g of f of x, I'm going to write the g function. It's the cube root of 2 parentheses, and then I have x plus 3. And inside the parentheses, I have to plug in my f function, 1/2 x cubed minus 3. 1/2 1/2 x cubed minus 3. So I plugged in my f function into my g function. Usually the operations will kind of undo opposite of each other. So first, what I notice is that if I distribute it in 2 to 1/2, then I get 1. So these two things undo each other. So I still have the cube root of x to the 3rd minus 3 plus 3. What's minus 3 plus 3? 0. So that cancels. So I'm left with the cube root of x cubed. Anytime I cube a cube root or cube root a cube, they undo each other. So I'm left with x. So if f of g of x and g of f of x both equal x, then you can say, yes, these are inverses. Yes, they are inverses. Over here, we're going to do the same thing. So I'm going to have to write out f of g of x. F of g of x. And if I write my f function, it is the square root of 4. I have to leave myself a space for the x minus 3. Inside my space, I'm going to have to plug in the g function. So if I plug in my g function, I have 3/4 x squared. Okay, so now I'm going to look and I'm going to see if anything can cancel. What I notice is that if I'm multiplying by 4 and dividing by 4, those are inverse operations, so those can cancel out. So I have 3x squared minus 3. Are these inverse operations if I have multiply by 3 and subtract 3? No. So is there anything else I could do to reduce this down to x? No, I would have to get rid of the 3's before I can cancel out the square and the square root. So I'm not even going to check the other one because this doesn't reduce to x. So I can tell you that these are not inverses. So either the operations will all cancel out and you're left with x, or they won't. Like, don't force it. They're either inverse operations or they're not.
Okay, we have a question.
Yes.
On first. The last one of you have put an 8 on the outside of the thing. You got it.
Where?
No, right there. You put it so that the last the bottom.
This
You
one?
put an 8 right there. Why you put this?
I put an 8.
Next one. Yeah, put it here.
Oh, no. It was a 5 and I marked it out
Wait, why did you cross it out?
because the fifth root and the fifth power, those operations cancel.
Wait.
This and this cancels. Good question. So we are done for today. I encourage you to go and do the front side of your homework first. It's just graphs. I mean, yes, you've got a lot of writing because you've got to write down the points, but it's just graphs. Go do the front side first.